Alright, the goal for today is to be able to graph linear equations when they're given to us in slope-intercept form. We're going to do this using two different methods. For our first method, we're going to create a table of input and output values that we can use to plot points and then connect to create our lines. When we do this, we have to include at least 3 points unless we know for sure that the line is linear. If we only had 2 points, it's possible that we could have a point here and a point here, and while it could be a linear function, it's also possible that we could have a function that goes through both of them but is not linear. So having that third point ensures that that function is going to be linear. So in this example, we have this equation of negative 2x plus 4, and I'm just going to pick 3 points that I would like to plot. So for one, I might pick x equals negative 1. I might also pick x equals 2 and maybe x equals 5. Again, it doesn't matter which 3 points you pick, just as long as you pick 3 to ensure that they are in a straight line. So using these input points, I'm going to find my outputs. So I put it into the equation for x because it's in the value of x. So negative 2 times a negative 1 is a positive 2, plus 4 is going to be 6. 2 times a negative 2 is negative 4, plus 4 is 0. And 5 times a negative 2 is negative 10, plus 4 is a negative 6. So using these 3 points, now I can plot these. So negative 1 and 6, 1, 2, 3, 4, 5, 6 is one of my points. 2 and 0, so 1, 2, and 0 stays right here. And then 5 and negative 6, so 1, 2, 3, 4, 5, and negative 6 is 1, 2, 3, 4, 5, and 6. Now using a straight edge, I can connect these lines together to graph my linear equation. Okay. Didn't quite do it perfectly, but it's pretty close. So that's one method we can use. The other method we can use, though, is actually a little bit faster and doesn't require a table of values. We've been working with linear equations for a little while, and we've discovered that y equals mx plus b. And this is what we call as our slope-intercept form. It's called slope-intercept because the m is the slope and the b is the y-intercept. Slope being the change in the rise over the run, and the y-intercept being the place on the y-axis where it crosses. So looking at this equation, we have a slope of negative 2 and a y-intercept of 4. When we graph our equations, we want to start with the y-intercept because it gives us one point that we know for sure. So in this situation, our y-intercept is a positive 4. So 1, 2, 3, 4. So our line's going to cross the y-axis at 4. From there, we know that the slope is negative 2, which can also be written as negative 2 over 1. Meaning that it's going down 2 for every 1 unit it's moving to the right. So if we do this, we go down 1, 2, and over 1. Down 2, and over 1. Down 2, 1, 2, and over 1. We can continue that. We can also move backwards into the negative direction by doing the opposite. So instead of moving down 2 and to the right 1, we're going to move up 2, 1, 2, and to the left 1. 1. Up 2, 1, 2, and to the left 1. Again, we can then take our straight edge and make this a straight line to graph our linear function. So now we've graphed that linear function. It's the same linear function, and we've done it twice. So we should have the same graphs. Depending on the strategy that we use, we might have a different number of dots on our line, but it is the same graph.